Hello everyone. Today I am going to continue my lecture on fluid mechanics. Fluid mechanics. Today topic is uh, to find the acceleration of a fluid particle in a flow field, right? So we have already seen that the uh, material derivative, material derivative of any function f is equals to partial derivative of function with respect to t plus u delta f partial derivative of function with respect to x and v partial derivative function f with respect to y and w partial derivative of function with respect to z. So here we want to acceleration of a fluid particle in a flow field, right? So where f is the field variable like like pressure, temperature, uh, it can be density or velocity, velocity v, right? So velocity v. So if we want to acceleration of a fluid particle, right? So here f should be v, because we know the rate of change of velocity is acceleration. So acceleration a equals to rate of change of velocity. So here we will put value of v in place of f plus u del v by partial derivative with respect to x, v partial derivative of v with respect to y, and w partial derivative of v with respect to z. So we know velocity v equals to u I plus v j plus w k, where I, j and k, these are the unit vector, right? I is the unit vector in x direction, j is the unit vector in y direction, and k in a z direction, right? So if we put this value a equals to here, if we put this value u I plus v j plus w k, this is equals to partial derivative of velocity u I plus v j plus w k. This is right, with respect to t plus u partial derivative of velocity with respect to x, here u I plus v j plus w k, and plus v into partial derivative of velocity with respect to, here it is v, right, with respect to y k. So this is plus w into del w by del z had u I plus v j plus w k. Okay, so what we will do, just separate. For example, in a left hand side, this term del u by del t, I plus del u del v by del t j plus del w by del u and dt, right? This is not del, this is d, right? Full derivative, right? This is k. These are equals to, these are the unit vector. Some people are using cap or some people are using their, right, in this uh, fashion, or some are using cap. So both are same, right? So in a right hand side, uh, what I will do, I will separate in I terms. For example, in a first term, del u by delta t plus, here this is this term here, this term, right? And in a second term, this is I term here, and third, this is I, fourth, here it is I, right? So I'm writing del u plus second term del u by del x plus v del u by del y plus w del u by del z, and this is I. Plus similarly, I'm separating in a y term, so j term, right? So j, similarly here, del v by del t plus u del v by del x v del v by del y plus w del v by del z into j. Similarly, del w by del t plus u del w by del x plus v del w upon del y plus w del w by del z into j, into k. So now what we will do, we will compare in both side in I terms. Here if we will see here, right? So here we will see I only, compare with I. So I terms. So del u by del t is equals to, here I can write it ax, means acceleration in x direction. This is equals to, this is equals to uh, this is equals to del u by del u by del t, del u by del t plus u del u by del x v del u by del y plus w del u by del z, right? So we can write ax means acceleration in a x direction. We can write this expression. So acceleration in a y direction, we can write here, because this is del u d u by del t. Here it is a x I plus a y j plus a z k. We can write acceleration x direction, acceleration y, acceleration z direction, right? This in this place, right? So we can write this one. So from here we will get this one. So similarly a y. So here in a u x direction, this is u is there. So similarly on u v w is there. So similarly we can write for y del v by del t plus u del v by del x plus v del v by del y plus W del V by del Z. And similarly, A Z, acceleration in Z direction, del W by del T plus U del W by del X plus V del W by del Y plus W del W by del Z. So these are the equation of a fluid particle, right? Okay. So here this is called, these terms del U by del U, these terms are called local acceleration, local del U by del T. This is local acceleration, acceleration, right? This is local acceleration, and this is the acceleration due to the convective term, right? So these are called convective, right? Convective, convective acceleration, acceleration, right? Even fluid is steady. So del V by del uh, dt, uh, even fluid is steady. So this term may be zero or may not be zero also. May not be, uh, can be this one, can can be zero or cannot be zero. Can be zero, or maybe non-zero term also. Non-zero, non-zero, right? So what is the reason behind? Because even fluid is steady, so in a study we know del U by del T, this term will be zero, and del V by del T also, and del W by del T. All these value will be zero for the steady flow. Steady means at a point the velocity constant with time. There is no change, no 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 change in the velocity with time. So this is the study, right? So so in this case only acceleration will be due to this convective term, right? So thank you very much. Today I'm stopping here. Okay.